Okay, vector field. Vector field is the vector value function. In which, for example, 2D, you associate in the domain all the pair belong to R squared. This is the domain, and the function give me a vector in 2D. The vector in 2D, we can, for example, express it like that: P comma Q, using angular notation, vector. But in general, P and Q are functions. P, this is equivalent to say P as a function x comma y, I, plus Q x comma y, j. This is in 2D. In 3D is similar. It's a triple order, belong to R3 space, and the function give me a vector in 3D. It's PQR. We have three components. And in other notation, P x comma y comma c I plus Q x comma y comma c j plus R x comma y comma c k. This is a definition for the vector field. Let's see example to understand vector field. Okay, the first example is very easy. This vector field is formed by two functions que es a constant, 2 and 1. That means que independent of the point, the vector is always the same. Okay, 2 comma 1. Suppose this 2 and 1. So the component x is 2, the component y is 2. You see another point. Suppose this point. This is the vector field. 2 comma 1. 2 comma 1. And so 2 comma 1. 2 comma 1. It's a family of the vector in any point of the space. 1, 2, 2 comma 1. This is very tedious, do by hand. However, using GeoGebra we can do that. Okay, this is the vector field 2 comma 1. Okay. Okay, in this second example, no. In this second example, the vector function is x comma 0. So 0 is constant, but x not constant. Suppose this point, okay, 1 comma 1. But the vector field in this point is 1 comma 0 because x is equal 1. It's something like that. And this point, que 2 is 2 comma 0. Entonces the amplitude is 2. And this point is 3, is 3. Something like that. So this is 1. And this is 2. And the negative direction is the same. This is 0 and nothing, no vector. Here, no vector. But negative 1 is opposite direction. And negative 2 is opposite direction here. Negative 2 here. Negative 2 here. Okay, this is the vector field And the second example, the sketch of the vector field. This is a sketch and GeoGebra of the vector field x, 0. Okay, this is the third example, a little bit more complicated, in which both component is variable x, y. Suppose one point here, 1, 1. This is a point 1, 1. You associate one vector que es 1, 1, and the vector 1, 1, 1 apply here is like that. So the one component is 1, x component is 1, and second component or y component is 1. Suppose this que es 2, 2, entonces something like that. It's completely radial, so in opposite direction it's like that, like that. Here is negative, negative 1, positive 1, negative 1, x component positive 1, like that. And the origin is 0, is 0, 0, entonces 0, 0 vector, null vector. Here is 0, 1, 0, 1 is a vector like that. Here is 1, 0 is a vector like that. Now here is exactly the same, and here is down. It's completely radial. This is the point 1, 2, this is 1 in x and 2 in y here. Okay, let me see in detail in GeoGebra. Okay, this is the graph of the third example in GeoGebra. You see that the vector field is completely radial. Okay, it's radial from the origin of open in any direction.